So does he not fall? Let's look at this real quick. So if I click there, that transform has him at position -1633. That should be the exact same height, but maybe moving from one collider to the next. So you want to kind of.
Seems to be where he falls over. Is that right?
Yeah. So you kind of want to do. So these individual guys have a box collider on them. So if we remove the box collider from the individuals, well, let's see if we can add it to the full one first. So because these guys are all children of this top guy, let's try to add a box collider 2D to that. Okay, so it kind of pops it up here, but we can move that. So now I'm going to go ahead and click on all those guys. And let's just turn the box collider off for him since we're just experimenting with this. So I just hit the little check mark next. I highlighted all the subfloors, if you will. Turn the box collider off for those, so they're no longer a player. Then let's go back to floor, and I'm going to edit the collider on this guy. So we're going to stretch it out to kind of cover the stuff. Drag it down. Something like that. And let's see what the baby does. He's still falling over on that. So is this my, let me go back to the player. So did you guys have what kind of collider did you have on the baby? Box collider? Okay, so this is just him moving really slowly, correct? Well, we have movement turned on.
Yeah.
Baby movement. Oh yeah, here's his speed right here. So maybe put it at something like that. Okay, fair enough.
Are you using on the floor rigid body?
On this floor here, I did not put a rigid body. The individual floors do have a rigid body.
Yeah, because when I tried to, I think somebody suggested that not to have rigid body on them. You can actually freeze the position so they don't really fall or something like that.
Well, yeah, but it's not the issue with that is it's not a situation of whether it falls or not. That's what we did with the gravity scale by setting it to 0. It's the collider, my understanding is the collider will not function if the rigid bodies aren't bumping into each other. So we have this collider, but you have two rigid bodies that are smashing into each other.
I don't have rigid body and
it still falls?
No, they're still in position. They don't fall.
No. It's not that the fence will fall. It's that I'm afraid the baby won't land on it because the ground is not actually a rigid body. We can look at that here. Well, I can't turn off rigid body? Well, yeah, I will. Just surprises me that I couldn't turn it off. Ooh. Baby almost toppled off. Yeah, so that's actually interesting. In the 3D, if I'm using rigid bodies on 3D objects and I'm using box collider 3Ds, so by default, any game object that you drop in that's a 3D based thing comes with something called a mesh collider. And mesh colliders only work with non-rigid bodies. So this would be the behavior you would get from a mesh collider if you were doing 3D Unity. But my understanding is that if you're wanting, is the baby, does that not have a rigid body? No, he does. So the second we add a rigid body to one of the two objects, the mesh collider would no longer function, is my understanding. It only works on non-rigid bodies. But these 2D objects don't come with a default mesh collider. So we're adding colliders if we want to add colliders. I guess it surprises me that we don't need a rigid body for the collision to, well, we don't need a, not that we don't need a rigid body for the collision to occur, but we don't need a rigid body for the physics to naturally occur. Because if this guy isn't a physical thing, you know, I've been knocking on the table, this is actually a rigid body, how does the physics engine know to treat you know, this as the baby landing on it as if it would be, I guess, physical? I don't know the answer to that. Unless it treats the 2D box collider as a rigid body. I guess that's possible. Just for the sake of argument here, let's go ahead and let's remove the rigid body from the baby. Oh, then he won't fall. So that's not going to work anyways. Yeah, that's interesting. So with this in mind, we would take the box colliders off of here. Now, really one issue with this though, it's just kind of playing devil's advocate, is when we expand this out, so obviously our game level is going to be bigger than just this little block here, right? We're going to get to a point where we can't, I mean, I guess we can just keep putting, you know, our custom box colliders along here, but kind of the idea here is we're going to have all our floors underneath this this one thing. So we almost need, so I guess let's take this opportunity to show something else. So we might call this guy what, like a long run. Oh no, you're still running into the same problem. So let's say that these guys here, so you know, let's say that we call this a medium runway or medium length block. Then we have a small length block, and maybe we have a super long length one or something like that. So, and what we would do is we would create these as something called a prefab, which I'll talk about here in a few minutes. So that way we can reuse it multiple times and just drag it in and it works. Well, the issue is we're going to run into that same situation where if we put two of them back to back, it's not going to be, you know, you're not going to have the consistent runway. Does that make sense?
Yeah, some of them might go a little bit up.
Well, but it seemed like even if we had them right on top of each other, it still had a problem associated with it. So what Tim had suggested at the end of last class, so let me go back here and let's take, I'll turn off the box collider on that. Let's put the box collider back on these guys. Let's make sure our baby falls again. Oh, he's not falling anymore. Box collider's off of that. It's back on these guys. Certainly the rigid body wasn't causing the problem.
Doesn't seem like it.
That is the problem. But this is zombie baby now. He's just dragging along the ground. Why would the rigid body? That's interesting. So it seems like what the rigid body does, let me turn the box collider off now. Let's just drop it. Should fall through, yeah, okay. So let's see if I can edit these box colliders. I'll turn them back on. Can I edit them all at once? Okay, good. So I'm gonna lift ever so daintily. Let's just actually do that with just one of them and then we'll duplicate it. So let's delete those guys. Click on this guy. So I raised the height of the box collider quite a bit. So my theory here is that the rigid body is mapping the shape of the object. So you do get those the little slopes, and the box collider wasn't passing it. You know, we were being too close to the exact edge. So now I've made the box collider. Let's just really exaggerate it, just for the sake of really testing this. All right, so box collider is definitely, I mean, this baby is going to be hovering above the ground is the idea, right? So then, that's on the floor. So we saw before we can remove the rigid body from this. Oh, wait, no, the rigid body is what gave it the fallover effect. That's right. All right, so that's going to be one piece of our floor. Let's duplicate this guy now. Let's do 3 of them. All right, so that's 3 floors in a row with, you know, the baby should hover above that. We have the box collider turned off for our top level thing. See what the baby does here. Yeah. So that seems to be the issue. When you turn on rigid body, it tries to mimic this thing as, you know, a real thing, right? Now, only if we have a collider on it do we say real thing interact with physics. But when we say this guy's a real thing, it actually surprises me why the box collider wouldn't draw itself completely around the rigid body aspect of it. But I made the rigid body a lot taller here to keep it from possibly interchanging with these little points. Now, let me try this. Go back to, let's just take this collider off and we'll re-add it. That way it comes in with the default. Okay, so that's the default for it. And it looks like kind of the points are right at the, you know, the box collider is kind of like a tie at the top of those points. So I'm going to do nothing else to these except just duplicate this guy twice. And let's see if we're back to our other problem. And that should, if that's the case, it should give us some confidence in how that rigid body is automatically happening. Oh, he's not falling over. So what changed? What did we do differently that's causing him not to fall over before, but he was falling over?
Sometimes I think it's the speed too, which you go over. Because you go slower, he seems to fall over more. He's more likely to fall over. Something like that.
If he goes slow, he's more likely to fall over?
Yeah.
Oh, okay, I get it. Now, I didn't actually test that when I had them higher. So let's go test that.
I don't know that it's both things. It seems to be like between where the fences are. At least on mine.
Yeah, no, I get what you're saying, like that transition.
Yeah.
And my idea there was I was going to overlap them. So is the problem Let's see if
It
that's.
seems to automatically unoverlap them.
That's what mine does. Like once you play it, they like spread out.
Yeah.
Oh, really?
Yeah. I think something with rigid body is forcing them to do that too. Because when I took the rigid body off, it didn't seem to do that.
Oh, so maybe are they bumping into each other?
That's what I'm wondering. Is this somehow they both hate this person?
So you think it's catching the edge?
Mm-hmm.
And I assume then you kind of moved them apart like this. Eh. That is weird. Oh, hold on. This guy is dropping. So when I bump there, I'm knocking it down. So that says this is an interaction between these dudes. And let's take the rigid body off of this. All right, I don't think it's happening anymore. So it seems like the issue is the interaction between the rigid bodies that are the fences, the ground guys. They're bumping into each other and causing each other to kind of like get wiggled out of room. Like you have some bricks next to each other and they're having some interaction with each other. It's actually interesting. So if we take the rigid body off, what other impact does that have for us? Because it seems like the baby is still acting. We look at rigid body here on the baby. Now, this was something that Tim pointed out last time, is we could have come in here to our constraints and froze the rotation for our baby, which just says constrain that position so that it never flip-flops.
Yeah, but then
I'll-
we suggest you to remove the rigid body so you don't have to.
Correct. Yeah. So, but I mean, actually, would that have worked? Because freezing the rotation on Z is that's the right one. So that would keep him from tipping over artificially, right? But we would still then have that issue where you have those other rigid bodies interacting with each other. So you might have like the fences getting off a little bit. So I'm trying to think what's then the benefit of having, because definitely on 3D side of things, the only way to have things that are just that aren't rigid bodies to interact with each other through natural physics is with the mesh collider. So in this case, we have a rigid body baby interacting. And did we prove if we remove the rigid body from the baby, it'll still interact? I don't remember if we proved that or not. Let's remove the rigid body from the baby. But he still has his box collider. Will two box colliders without rigid bodies interact? Oh, he won't fall. Yeah, now he doesn't have gravity. I just don't know. Can't add a conflicting component. Oh, did I try to add normal rigid body, not rigid body 2D? Yeah, I did. So is the rule of thumb then for 2D? Why isn't he moving anymore? Oh, I maybe hit Control Z too many times and did his speed slow down again? No, that looks like the same speed he had before. Oh, I take his mass. Yeah. What did I make his mass before? Was it 0? And then it puts it at 0, 1, 1 or whatever. Say this again? Yeah. Because the gravity scale for him, that doesn't matter because that's just how fast he'll fall, right? So gravity scale of 1 should be, what is it, the 2.73 meters per second at terminal velocity? I think that, at least that's close. It's been a few minutes since I had that, but I think that's in the ballpark. So I think that would be a multiplier of that if you wanted him to drop more quickly, give a gravity on a different planet or something like that. So it seems then for 2D, he just fell over. I had him going backwards and he fell over. And that is with no rigid body on the floors, right? So it actually did not fix our problem.
Maybe you can change the body type to like static, or your body of the floor.
Well, yeah, probably of the player. Because right now the rigid body, the floor doesn't have a rigid body.
Yeah, if you just insist on adding it to them, static.
Yeah, so the rigid body on the player, we can make. Let's try to make that static. I'm not sure what static necessarily means. Okay, so.
This means that it doesn't, simulation will not allow it to movable object.
Yeah, so
That's why it should be
well, right, but we still are going to have that issue with him tripping.
If you put them static on the floor, I think that.
But the floor right now doesn't have any rigid body.
Yeah, I'm just saying.
If we do the rigid bodies because we decided the problem is that these guys are bumping into each other. If we make them static, bumping into each other won't have an impact. But right now, there isn't an impact between them, yet they're falling over. The baby's falling over. So he wants to do this. He wants to add a rigid body 2D. He wants to make make that guy static. Which means that it won't fall or anything. It's a physical thing, but it's not going anywhere. It's just physically right where it's at. We'll have the baby be a dynamic rigid body, so a normal rigid body. So he'll still fall. I mean, I just saw him like hit. Yeah. Yeah, so I mean, you really don't want the solution to be make a higher floor so the baby's floating over the floor.
Or maybe it's actually doing what it's supposed to be. It's a fan, so it's gonna fall over.
Well, yeah, but we just happen to use that. We wanted this to be a smooth floor. So there's got to be a
I have a smooth floor and I'm still getting the same problem.
okay with multiple things put together, whether there's rigid bodies or not.
Without rigid bodies, it seems to happen less often.
But not never.
But yeah, not never.
Okay.
Sometimes just catches like right between the two.
Okay. But it's always between the two? Okay. So then, so far, our only real solution then was turning on this box collider for. Oh, we're missing some fences, but doing something like. Well, let's go ahead and do a prefab. So we're gonna call. We're gonna call just this guy a. Let's call this a short. Well, no, we're gonna still have the problem of them bumping into each other.
I think what it is, I think if they were perfectly aligned, my guess is it's just getting slightly off alignment or something, and that's what's throwing it off.
Right, but the
Tiniest bit, so it'd be almost impossible
to get them.
humanly put it in there unless there's like a control of the game.
Yeah, unless let's look at something here. What if I make? Let's put them at exactly 0, so there's no floating point. And then we'll just raise the baby up some, so he still gets the fall effect. So maybe it was the decimal points on that. No, he just rocked on it. What if we did this? Let's edit the box collider on this guy. Let's just make him a little farther on each end to give us some like synthetic overlap. Okay. And then let me delete these two. And let's duplicate those two. And now, really, they just have to be kind of close, right? So now we're hoping the rigid body component then of those guys isn't impacting each other. Oh, it definitely is. Go ahead.
Angular drag, you can change that, but it's default to 0.05.
Yep.
And if you turn it to 1, it falls over a lot.
So if you take it to 0, the idea is that he shouldn't hit individual things. Although I'm not actually able to get him to, well. But this also then gives us that, that effect where our fences aren't necessarily, I mean, we have like gaps. All right. I want to say this might have fixed the rigid body problem. So that would support what you said about, the pixel perfect type thing. So now we've given ourselves kind of a buffer space for the rigid bodies where they don't need to be so pixel perfect other than our visual eyes being able to see them. Like we see there's a little gap between the fences. So it appears to be the rigid body system that is causing that speed bump, if you will, and that the box collider. Oh, look at that! Sign of the apocalypse. All right, so then let's go back here. Let's remove these guys, and we'll do the angular thing. Because what I really want to avoid is having to do the wrapping of the entire object in the box collider for a couple of reasons. Because it takes away our, actually, I'm going to just do this. I'm going to remove the box collider, re-add it, so it gives me the default size. But that takes away our flexibility for kind of designing levels. Is we don't, now we have to use these longer streets. Well, there's never going to be a street long enough, so now you have to kind of customize each of your platforms with a box collider around it for its exact length, which isn't the end of the world, but at the same time isn't necessarily the most convenient. All right, so let's make sure this happens again first. So we'll do our original overlap where they're clearly overlapping with each other. Okay. Okay, so he wasn't too hard to get him to hit there. So then you wanted to go to the so you're doing this on the rigid body on the player? So the angular drag here you're putting at 0. Even at 0?
I don't know if it's a combination of anything else.
Oh, no, he still fell over. Killing me. All right, so we can put our freeze rotation on Z. So he shouldn't be able to fall over now because we've actually constrained. Okay, which then means that underneath our floors here, I stop this. These guys, I'm trying to think, what's the advantage of them being rigid bodies? I mean, historically, I would have said the advantage of something being a rigid body is that the natural physics engine acts naturally with it. But in 2D, it seems like that's not required. So I wonder what the point is. I'm going to say for now, let's take the rigid bodies off of the fences. Just leave the box colliders on. Seems to behave the way we want it to behave. Okay, so at this point, I don't know why you would need 2 rigid bodies for collision between each other. Clearly, we need the rigid body on the baby, but the rigid body on the baby can collide with a 2D box collider, no problem. So let's leave them off for now and see if we stumble upon something that lets us know a better a use for a 2D rigid body on something that the baby's interacting with. Because I think right now there isn't a compelling reason to do it. So right now our actual fix is what Tim brought up at the end of class last time. But at least we explored a bunch of stuff. And that is to go into the rigid body on our player, our baby, and say, we went under constraints and said, freeze the rotation on Z.
move it really slowly and you hit that edge, the baby just doesn't go anywhere.
Because he catches.
So because he catches, yeah.
Is that still
You kind
you?
of have to like back up and go really fast to get over.
So you've had that happen already?
Yeah.
Even with the rotation?
Yeah.
Oh,
So I was just curious if it would still catch at all. But so it's only if you're going really slowly. So I think it'd be like very rarely that you'd run into that in a game, but it is there still.
Yeah, that's interesting. But that kind of goes, I mean, if we kind of go historically, there are things like that in some of our old 8-bit video games where like these weird thing. I mean, we don't want it in ours necessarily, but it is interesting how that is working.
I mean, I think it has to be a rare situation to run into it unless you're trying to get it. But yeah, it is just kind of a curious little thing that happens.
Are we freezing the rotation on our floor too?
I took the rigid body off the floor, so there is nothing to freeze. The floor doesn't have a rigid body.
Is that what we want to? So I should take it off.
I would take it off. And the rationale we put for that right now is that we can't come up with a compelling reason to put it on. And the less components, the better, because that now has a would have a performance impact on the game. How can you make edges not? Let's look at the sprite renderer, because there used to be a thing in a different game engine I've used where you could duplicate a sprite. Let me try this here. So I'm going to delete the other floors. I changed the draw mode. Yeah, it still spreads it out. It's very interesting. Because the way it would historically work in some of the old game builders is you would actually have a lot of times, like look at Mario, the ground is made up of basically little cubes that all look the same. Mm-hmm. And instead of having a big long object like this, you'd have cube next to cube next to cube next to cube, just effectively Legos for building your scenes. But then how would they avoid?
Well, because if you do the tile, I think the reason it's giving you a little space between is because of how the sprite's cut. So if you cut your sprite exactly around the little block, then you can just tile it, put it all in one box collider, and it would work fine.
Right, but so that's not what we have here. Do we have a better sprite that we can use for our floor in our assets? Here's the sheet. What's this guy? That doesn't look like floor. It's like a treasure chest thing. These are like signs. So let's at least test that. So I'm going to go back to the asset store here. Let's just do a search for 2D floor. Free only. Pixel texture pack. Okay, it seems like it'll give us something. So let's download that guy. Well, and actually, is this the first time we went to the asset store? Oh, okay. So the asset store has a bunch of built-in stuff, so you don't have to go to other places. The site I took you to before has just a lot of 2D art on it, where it looks like it's fairly limited here on the asset store. But the asset store is a good way of, you know, conveniently bringing stuff into your projects. You can also buy stuff on there. So if you want higher quality things, you can pay for it. But usually, you know, at least when you're learning, you're going to click on free and just see what it gives you. So let's take a look at what we just got. So we just got this folder here called Pixel Textures. And let's look at scenes. So those are like sample scenes. Let's look at the textures, floors. Yeah, these really seem like it's for a 3D. Well, no, actually, no. This could be like a kind of a brick type floor, right? Sideways. This is the one that might be kind of the better one for what we're looking for. So if I drag this guy out here, oh, is he listed as, no, he's listed as 2D. So it wants me to create a sprite first. And then it wants me to add this guy to the sprite. This is a floor texture, sprite renderer. Oh, maybe it wants me to use the materials. So here's like our marble floor. So this guy is letting me tile it, but I'm not getting it to show up yet. We have this marble floor material associated with it. And I'll talk about materials here in a second if we get this guy working. So let's take out the floor guy here. So he's out of the way. We're going to say this is our floor. So our floor has a sprite renderer. We have this material associated with it. But there's no sprite associated with that. So let's go back here. Let's go to textures. Let's go to floors. So those things are not giving me an actual sprite. If we click on their scene example, so a lot of times when you get asset packs, they give you like scenes to check out that they've built. So let me click on this example scene. We'll save our scene. So the example scene looks like this. So we have some different floors available to us. So this guy is, so they're not doing it as a sprite. That's a 3D object. Okay, so the way they're pulling the floor off, or we just want to pick one of these. Let's just use this. Well, here's this kind of like a stone. Even though it's a wall, we can use that as a floor, right? Let's use that as our floor. So I'm just going to copy that guy. We'll go back to our scene, main. I'm going to paste that guy in there. Let's just see what that looks like when we run it. Gives us a little square, but I don't see the, yeah, there's no material. It's showing it with a mesh renderer instead of a sprite renderer. Let me go back to this scene example. See, they put a light above there, so I guess let me show you lights. So right now you see that this floor looks black, basically you can't see it. So I'm going to go ahead and put a light in the sky. So I'm going to right click over here and we're going to create a light. We're going to create a directional light. So think of that like the sun. All right, so this guy is pointing effectively down. So now we're going to maneuver, oop, that's size. We're going to move this guy up into the sky. I'm going to zoom out a bunch here. So we put it at a height of, let's say, 20. We'll put it at a position of 0. And then the Z is going to be 0 because we don't want it to have any depth. Now notice, well, I think we'll notice that we can see the brick now because before it wasn't lit. So a sprite is self-lighting, where this concrete wall thing we did here, if we call this our, a floor, this guy, let me go back and show the player. Here's the player. The player is a sprite. So sprite, anything that's called a renderer is something that draws onto the screen. So a sprite renderer draws a sprite onto the screen. Well, this example thing is, instead of showing the ground as a sprite, it's showing the ground. This guy here, well, that's our sprite version of the ground. Let me delete that. It's showing our ground as this guy's an empty object. Okay, so originally it would have created it as a create empty. And then it started adding stuff to it. So it created this mesh filter, which actually probably is not necessary. It created a mesh render. So instead of drawing it with the sprite engine, it's drawing it with this thing called the mesh renderer. And mesh render has like things related to whether it casts shadows and stuff like that. And those are going to make more sense if you're dealing with 3D. So mesh renderer is not something that's a 2D specific thing. It can also be for 3D. Then you have a material associated with it. So a material, think of it like when we saw them in the screen here. Notice that they're like these circular blob looking things. So a material is like, think if you go to a store and you buy, some cloth or something like that, you're wrapping an object in this. So it's covering, let's say, all sides, which in 2D, it's only going to be one surface. But you can actually create your own materials. Let's say you wanted something to be red. You can right click here. You can say you want to create a material. and then you can give this guy a, a color of red or something like that, and now you have a red material that you can throw on something. So now you would have a red floor or something like that. So before, I think it was, or maybe 2 classes ago or something like that, I had mentioned that in 3D we have primitives that we can use. So the theory here would be that I should be able to come in, I should be able to create a, let's see, under 2D we just have sprites. So I'm going to create an empty, this guy. I'm going to give it a, we'll say its position is okay. It currently has a scale of 1 by 1 by 1. I'm going to go ahead and drag, we're going to need a render on that guy first. So there's my empty. I'm going to go to add components, and let's add a mesh renderer to this. And a mesh render is going to require a material. Now, is this guy lit up at this point? He is not. So maybe it needs that filter. See, I don't know how a mesh filter would work on this. They had previously used a quad. So a quad is, it actually is a 3D object, but so they're saying we're going to put a square in front of this, and then we're going to shine our material through that square, and then that's what's going to, I guess, arbitrarily light it. But we saw we needed a light above otherwise. Let me see if I can turn that light off. Yeah, if I turn the light off, it doesn't get lit. So it's not a light thing. It's just how do you paint onto that square. But does this actually solve our problem? So we can create our own, let's call it red block primitive. But now if I come back here and I go to my floor and I want to duplicate this guy several times. And let's go ahead and create an empty. We'll call this guy floors. And actually, before we duplicate them, let's get the box collider and stuff on them. So I'll go ahead and drag my floor into floors. It's the same thing we did before. I will add a box collider 2D to that. Okay, fair enough. Then we'll go ahead and start this guy next to the underneath. Well, actually, let's go a little bit to the left. So duplicate him several times, drag them over, and now the size of this guy is, well, that's a scale. Does that really help us? I think there's a way you can drag over more quickly. Like literally duplicate these guys. So this is, well, I'll show you how this works. So this is on a position of, let's do -0.2. Then this guy would be a position .8. Does that make them right next to each other? 0.79. Does that look better? That looks better. So that means that the distance is 0.99 away from each other. So this is 1 times 0.99. This is going to be plus 2. Huh? No, but watch what I'm going to do with the math. Watch what I'm going to do with the math. I think there is a way to make it, but I don't know how to do it. I've seen them do it in some videos. Like drop them so they're right next to each other of the fixed size. But what we can do is, since we know they're 0.99 away from each other.
So next one position, we just type it in instead of dragging it.
So I'm just going to stop that because this one's right on top of it. So this is 1 times, so we're going to say this guy is going to be that plus 2 times 0.99. And that positions it there. And then what I'll do is so this guy is plus 3 times 0.99. But I'm going to copy that. This guy is 4. This guy is 5. This guy is 6. So if anybody can figure out how to make them land more quickly, so we can just kind of plop them right next to each other in a mesh, that would be helpful. I don't know how to do that. So there's our box collider on each of these guys. Let's see if the baby falls onto that now. Yeah, he just got stuck. He's stuck again. Because now you have edges every 15 millimeters or whatever. What if we take one of these guys and stretch them out a whole bunch? It's not going to look right. You know what? We could do this with our material example. So let me try to stretch this guy. Oh, so that would have only worked if it was a sprite.
The size of the square. Instead of stretching it, just doing the side.
Well, I did. This was the scale.
Oh, I thought it was just drawing.
That's okay. What square do you want to change the size of?
The original. So yours, instead of stretching it, can we just make it?
Yeah, I mean that's effectively what I did. So that's 5 times on the. So I mean it should scale better if I go like this, but then we're still stuck with, we don't. It's not the right width. This is interesting.
Originally, is that just a pixel, or is it
Is what a pixel?
so you created that out of empty, right?
Correct.
Okay, so is there a size?
That's the scale.
Okay.
The size of it is its scale. So the default scale is 1 by 1 by 1. So when you apply the quad filter to it, it's the size of a 1 by 1 by 1 quad. So that's what limited our size. So it seems like the only thing that really works so far is putting the box collider around our surfaces. So you draw the thing however you want it to look, not worrying about pixel perfect or anything. Then you lay a box collider on top. You know,
Or when you duplicate them, can you convert them all into one object? So you can have one collider on them, on the whole object.
well, you can because we were doing that before. You know, when we had our other floors, so it looks like we didn't. There's no real advantage of doing it this way. Well, I guess unless we like this, do we like this floor better?
The best bet, I think, is to get a sprite that you can tile and it looks good.
But even then, does the tiling?
Because the tiling then just has one box collider on the whole thing. It's just one object.
Okay, but we need it as a sprite.
Yeah.
Well, so then we have one
Well,
of
you can essentially kind of do the same thing with the mesh when you stretch it, but not every mesh is going to look good stretched.
right. So we have. I mean, this is going to be a tileable thing, right?
Right.
Oh, I mean, it doesn't really look like a floor, but let's just say who cares? We'll make this guy 10 by 10 by 1. All right, so he's like running on like a lava floor or something like that. So call that guy floor. And that's using a sprite renderer where now we can choose tiled for it. Yeah, so it's not detecting that guy. What's his size?
You have to change the width and tile. However many times you want.
The width of X?
The width under size right in the sprite render. So,
Yeah.
Yeah.
Oh.
So you put that to have
I gotcha. So you could say something like that.
Yeah.
I gotcha. So that was. Oh, because the original size is 0.14.
Mm-hmm.
So, you know, if we give a size of 5 or something like that, that should give us plenty of space. And then you want to drop a box collider on this.
Mm-hmm. And then just make the X on the back collider match whatever that width is.
So we're going to just drag the box collider out. Because now, because we're using the built-in tiling engine, there's no edges.
Right.
That's the concept. So then it's just a matter of finding a floor.
That looks good tile.
Yeah. Well, this looks fine.
Yeah.
But yeah, I mean, so what she's indicating is that if you find things that are very close in size, width, and height, so a square or something very close to a square, you can then bring that in as a single sprite and then choose the draw mode for it to, instead of simple, which was the default, change it to tiled, which then lets you set the width of how many times you want it to duplicate that thing. So if we say 4, this is the number of tiles we have here is 4 divided by, what was it, 0.14? Something like that. So we should have, 4 divided by 0.14. This is, let's call it 29 tiles we have that it just drew for us. I don't think we have a half tile. I think it's going to show a full tile the whole time. So the camera doesn't follow us. We'll fix that problem later. But so this seems like it'll give us the smooth thing. We do lose some of that control over having some different textures because I wonder if we have 2 sprites next to each other that have, and maybe that's just a constraint on our game where we'll call this lava floor. Zombie babies, they can walk on lava, right? Or it's like walking on fire, maybe. Yeah, fire. But let's say it moves over to rock. So now you have 2 different floors right next to each other. You're still going to have that transition issue, right? Moving between those. So that might then be a constraint on your game design where you say, okay, and I think this is probably true. If you look at Mario, I don't, and I mean, obviously, I don't have the whole game memorized, but I can't recall a situation where floors right next to each other were of different types. You know, they were almost always divided up by, you know, the the pipes, right? You know, you had something that you had to get over in order to transition you to the next thing. So instead of a little bump, it was a big bump you had to get over. So yeah, I mean that makes sense. It's just very interesting that there wouldn't be some sort of blend. And my gut feeling there probably is. There probably is something that I just don't know.
You think right now there'd be something.
For the first time, something that. Go ahead.
Yeah, well, I was just gonna say, you think they'd have some way to do it.
Or maybe it's the weakness because I think I mentioned before that Unity started off as a 3D game engine, and then they added 2D stuff to it for people who wanted to. I mean, really, I think the motivation for that. I mean, for us, yeah, we're doing 2D stuff because it's kind of easier to initially conceptualize than when you start going into 3D and you're moving into the scene. So it kind of makes it better for a learning tool, at least initially, and then jumping to 3D isn't such a big deal. But at the same time, I think there's for instance, Flappy Birds, right? You know, that was a hugely successful whatever, and that was I don't know what tool that was made with, but you certainly could make it with Unity. In fact, I think there's a tutorial out there, like the Flappy Bird tutorial, and we might do something like that. But the platform is going to teach us a whole bunch of primitive mechanics. So, in any case, there is this thing where there was kind of this market for mobile applications because Unity is write once and then you can deploy. We can, do our build settings and we can deploy this guy to different platforms, iOS or Android, that kind of stuff, and it'll build a project for us. So we don't have to do it ourselves. We don't have to go and write this stuff by hand using the tools for Android Studio or Xcode, because we're using this tool to do it. So there's a market for making those kind of 2D fun type games. In fact, most time wasters are 2D type things, aren't they? So I mean, what have we seen maybe recently? I mean, like my current time waster is a game called Clash Royale. So, and I think that's 2D, but the character models are like pretty good, right? So it's not Zombie Baby, it's higher quality art than that, but it's still a 2D map. So, and we'll probably look at that because another style game we're going to do after this one is kind of a Zelda style, where it mimics 3D. Because I mean, if you've played Zelda before, you're kind of on this big, it's a 2D map, but you move up, which is kind of the idea of moving in, something like that. So instead of us just moving side to side with some jumps, now we're going to be moving into other things and then transitioning between scenes. And if you think about how Zelda works, when you go from one scene, what happened? It kind of zips down and puts you at the bottom of the screen so you see the next scene above you. So you can kind of plan out because you don't want to be at the top of the screen and just, what's going to happen next? What's going to happen next? Because you're right at the edge of the screen and you're wondering what you're about to bump into. So something, I guess, interesting there. All right, so let's see. We're out at 9:20. Is that right? Okay. So I want to quickly do something then here. We'll look at the animations for transitioning before, but I do want to show you. We're going to go into our movement script for our baby. So here's our baby movement. Let me just come down here to our scripts folder. And we want to capture that space bar. All right. But the idea of the space bar is jump. Okay, so we have the baby moving back and forth right now. But at the same time, we want to have this guy jump. And when we jump, we've already seen this happen one time. So when we want our rigid body to move from side to side, so our movement here is based on our move horizontal, right? That's our horizontal axis. Now, we also had our vertical axis. That's if we would use that in a Zelda type game, okay? But what we want to do instead is we want to determine that the space bar was just clicked. And we're going to create a scenario real quickly that says, is space bar clicked? If yes, do something. We're going to make them jump. So this is inside a fixed update, which, as Tim pointed out, is a 60 frames per second type of thing. That way everybody who's playing the game is going to have a similar experience. So we're going to say if input.get key down. All right, so get key down. This guy takes in a string. I think it's called input. Is it called key?
You can use the same type of thing you used on the other one.
Well, but you need the name of the key. So I think it's key code space.
Well, the Unity program has a built-in axis called jump or something like that.
Oh, I know what you're saying. I know what you're saying, yeah. I want to specifically show responding to a key.
Oh, okay.
Yeah, so I almost am positive it's mapped to the spacebar. I think jump is spacebar. So
You can
get,
change what it's mapped to.
okay. So get key down is key code space. So if that happens, if we currently have the space down, we want to add some, we'll let that do it next time. We want to add some force to our rigid body in an up direction. All right, so we're going to go ahead and create a vector 2. Let's call this up. It's going to be a new vector 2. And we want to give this a direction. So we're going to say vector 2 dot up. Okay, so vector 2 has a constant in it that's called up. And then the z will be 0. Is this not liking this? Oh, it wants us to give it a float. All right. We'll write this quickly the next time. I'll just tell you what we're going to do here first. I'll leave an error in here. That way it'll remind us. But what we're going to do is when this key is pressed down, we're going to create a vector 2 that's up with a force. So we're going to have this up times a certain like power or jump strength. And we'll have to see how gravity pushes down on us to kind of get that jump strength in, similar to what we had as speed. Then we'll apply that force. We'll add that force to our rigid body. So that'll push our rigid body up as gravity is pushing it back down. But one weakness we're going to run into at the beginning is you can do super jumps. Just jump, 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 jump. Okay, so now we're going to have to add logic in to say, if you're already jumping, you have to stop jumping. Make sense? All right, so we'll come back and finish that on Thursday. Then I'll give you an assignment over the weekend. Oh, this already is the weekend. No, well, that's the way it goes. All right, I'll see everybody on Tuesday.